Good morning, my friends. I'm Clover, and this is Genuinely Approachable Sudoku, and today we're solving IVIX by Philip Newman. As the name suggests, this is a 159 Sudoku. So we have normal Sudoku rules. We're placing the digits 1 through 9, ones each, in each row, each column, and each outlined 3x3 region. And on top of that, we have 159. So that means we have 3 highlighted columns, the first, fifth, and ninth columns. And these columns are going to tell us where the 1s, the 5s, and the 9s go in the Sudoku grid. So the first column tells us about the 1s. So for example, if we were to put like a 6 here, that would tell us that in that row, the 1 is in the 6th position from the left, so it would go right there. If we were to put an 8 here, the 1 would be in the 8th position from the left in that row, so it would go right there. The middle column does the same thing with 5s, so like if that was a 2, then 5 would be in the 2nd position from the left. And the rightmost column does that with 9s. So like if this was a 3, then the 9 would be located in the 3rd position. So 1s, 5s, and 9s. On top of that, we have some x's and v's in the grid. V's mark pairs of digits that have a sum of 5, and x's mark pairs of digits that have a sum of 10. And not all possible x's or v's have been necessarily given. There may be other pairs of digits in the grid that have those sums that just haven't been marked. So let's get started. So v's can only have the digits 1, 2, 3, and 4 because they have to be smaller than 5. So these guys are definitely 1, 2, 3, 4. Now this and this need to mark 1s. So because this is 1, 2, 3, or 4, this is going to be 6, 7, or 8, or 9, because these two have to sum to 10. And that means the 1 in this row is in position number 6, 7, 8, or 9. Critically, that means that it can't be in position 2 or 3, so neither of these can be 1. So this can't be a 1, 4 pair. That's going to be a 2, 3 pair. This has to still sum to 10, so this is going to be either 2 plus 8 or 3 plus 7. So that means that the 1 is in position 7 or 8, so it's over here. That all checks out. And that's also going to be 7 or 8. These guys are going to be 5, 6, or 9. This can't be a 6 because 5 can't appear in the 6th position. Up here, the 1s can only be in these cells because this is the digits 1, 2, 3, and 4. So we know that all 4 of those are taken care of. We know that 1 is in one of those 4 cells for sure. So that's positions 3, 4, 7, and 8. So this has to be 3, 4, 7, or 8. However, we already have 1, 2, 3, and 4 accounted for here, so this can't be 3 or 4. So the 1 has to be in position 7 or 8. So this can't have a 1, it must be a 2, 3 pair. And that is a 1, 4 pair. So to add to 10, this is going to be a 7 or 8, this is going to be a 6 or 9, that's also a 6 or 9, and that is a 5. That makes this a 9, which resolves this. And now we know which position the 1 it is in. It is in position 8 in this row. So that's an 8, 2, 3, and 7. The 8 resolves this into a 7. And now we know that 1 here is in the 7th position, like so. And it checks out too because we know now that 9 is in the 6th position here and the 5th position here, and that's all correct. 1 and 4 have to be in these cells because this is a V clue, but it can't use a 2 or a 3. The only remaining digit in this region that can possibly ever appear in a V clue is 3. So that's 3 telling us 1 is in the 3rd position, 2 telling us 1 is in the 2nd position right there. So 1 has to be in one of these two, one of these two cells right here. Now let's pencil mark our remaining V's. So this can't be 1 or 2, so that can't be 3 or 4. And there's a 1 in that row, so that is going to be a 2 and a 3. And that tells us 5 is in the 2nd position here and the 3rd position here. This can't be 1 or 4, so that also can't be 1 or 4. And there's a 3 in the region, so that's a 2 with a 3. Now, we need these guys to sum to 10. We can't do 1 plus 9. We can't do 2 plus 8. We can't do 3 plus 7. So this has to be 4 plus 6. There's a 6 in this region, so that's my 4, that's my 6. So 5 is in the 4th position here. 5 is in the 6th position here. In this column, I'm still going to need 1, 7, and 8. That can't be a 7. Now I'm going to look at these two cells. I need a 6 and a 9 here. So that tells me that 1 here is either in the 6th position or the 9th position. It can't be in the 9th position because there's already a 1 in that region. So that's a 6, that's a 9, 1 goes right there. In this column, I still need 1, 4, 5, and 9. That can't be 1 or 5. Those can't be 4 or 9. So that's my 1, that's my 5, telling me that I have to place a 1 in the 5th position, which is right there. Here, 1s have to be either in the 4th position or the 9th position. So there's a 1 there or there, and there's a 1 there or there. What else is looking nearly resolved? So in this region and this region, we have almost all of our digits. We need to place a 2 in this region somewhere, and there's a 2 right there that sees these 2 cells. So that's going to be a 2. And here I need a 3 and an 8. In this region, I still need 4, 6, 7, and 9. And I have 2 4s looking into this region, so 4 is eliminated from these cells, and that's going to be my 4. This can't be a 9 because there is a 9 in the column. So these guys are going to be 3, 6, and 7. 3 can only go there because of the 3 right there, and that's going to be 6 or 7. The remaining cells here are 6, 7, and 8. That can't be a 6, and so this can't be a 1 because 1 plus 9 is 10. It's not 1 plus 6, 7, or 8. So that's not my 1. That's my 1. That's my 1. So this is the 9 indexing that 1. This is the 4 indexing this 1. This now has to sum to 10, but it can't use a 1, 2, or 3. So it's 4 plus 6. That's now a 7 and an 8 and an 8. So 5 is in the 8th position. That is also provable by Sudoku. These are going to be 7 and 9. And here, my last digit in this column, I need a 4, and I need a 6 and an 8. Here I need 7, 8, and 9 to finish this row. And I need 2, 3, and 5 to finish this row. 5 can't go in those cells by Sudoku, so 5 is going to go right here. And also there's a 7 there indexing the 5, so I could have also just used that. 9 is in the 2nd position, so I know that's a 2, not a 3. Okay, my last 3 digits here are going to be 4, 6, and 8. That's not a 6. In fact, I already know where the 9 is here, so that's going to be a 4. These guys are going to be 2, 7, and 9. That's not a 2. It also can't be a 9 because that would give me a second 1 right below it. So it's going to be a 7 plus 3. That means 9 is in the 7th position, which is right there. 9 here is in the 3rd position, which is right there. 3 resolves this 3, 8 pair. Now I need to place a 2 in this row somewhere. That's the only spot it can go in, so it gets paired with an 8. And I think that we're just going to finish up with classic Sudoku. That is correct. Okay. Lovely. And that is how you solve Philip Newman's IVIX. Hope you guys liked that one. The link to check it out yourself is in the description of this video. And I will see you again in 3 days.